This is video number 5 for sections 6.1, 6.2, and 6.3. A quick look at quadratic functions. So we said that this whole new unit is on the topic of quadratic functions. Let me just briefly tell you what a quadratic function looks like. This is what's called the standard form of a quadratic function. Y equals ax squared plus bx plus c. A, B, and C are just constants, kind of like the m and the b for linear functions or the a and the b for exponential functions. The only restriction here is that the a cannot be equal to 0. Hopefully it's kind of obvious why that is. If the a was 0, this whole piece would drop out and I would be left with just a linear function. So the a cannot be 0. And we're going to have to figure out what the A and the B and the C do, what they mean, how they impact tables and graphs and all that other stuff. That'll come really more in Chapter 7. This is just a very brief introduction. I've put an example problem here. This is a quadratic function, but it's not quite written in that standard form. And so the first problem says, let's go ahead and fix that. Let's go ahead and rewrite it so that the equation looks like this. How do we do that? Well, the main thing I notice is the standard form doesn't have any parentheses in it. So I think if I can get rid of the parentheses here, I'll be all set. Perhaps you are tempted to distribute that exponent. We talked about that earlier in this lesson. Exponents don't distribute when there's a plus. So what you're going to have to do is you're going to have to write out what that means in detail. Squaring something means multiplying it by itself. Notice that I've created here a FOIL problem. Technically, I've created a situation where I have 3 items that I need to multiply. Well, we said earlier in the lesson, you can do this in whatever order you want. So pick the 2 that are the most complicated. To me, that's these 2. Work out the answer to this multiplication problem, and then take that answer and multiply by 2. Now, I don't want to lose the 2 here, so I'm going to do my work just right here in this space. This is a FOIL situation. X times x, x squared. The outer would be plus 1x. The inner would be plus 1x. The last would be plus 1. And when I clean that up, let's see, that's x squared. X plus x is 2x. Plus 1. I still have that parentheses there, don't I? That's to show the multiplication by the 2. I'm about to get rid of it. Now I just have a simple distributive situation, multiplying this 2 into all 3 parts. 2x squared plus 4x plus 2. And then I have a couple of like terms at the end. It's interesting because they actually wipe each other out. My final answer here, f of x equals 2x squared plus 4x. I have now put this thing in standard form. It matches that pattern. The a would be 2, the b would be 4, and the c would be 0 since it disappeared. Well, let's use this function now that we have it in the standard form. The next problem says find f of negative 1. That's very straightforward. We've done that a ton. That just means go to my function. I think I'll squish my work in over here and replace all of the x's with negative 1's. I'd have 2 times negative 1 squared plus 4 times negative 1. All I have to do is work out the math here, and I'm done. When I square negative 1, I get positive 1 times 2 would be 2. Looks like I've got minus 4 here for a final answer of negative 2. The problem underneath is very similar, just a little bit funnier looking. So now it says find f of c plus 2. Exactly the same idea. It just means go to the function. And this time, instead of sticking in a simple number, I'm sticking in this expression c plus 2. I just need to replace each x with c plus 2. Use that empty slot approach. And all that's left is to clean this up and simplify. The math really is going to be very similar to that math we did above. I cannot distribute this exponent of 2, so I'm going to have to write out what this really means. It means c plus 2, c plus 2. I can distribute this 4 to give me 4c plus 8. I'm really in a very similar situation to what we did before. I think I'll do that FOIL problem first. C squared, 2c, 2c, and 4. I went through the FOIL. Let's see, I've got a couple of like terms in that parentheses. I can make that a 4c in there in the middle. And I can distribute that 2 now, and then combine my like terms, and I'm done. It's kind of a strange answer. We're just saying that, look, if you stick c plus 2 into this thing, here's what you're going to get out. Well, finally, we're going to do a lot more with graphing quadratic functions later on. But let's go ahead and take a look at this particular function we've been looking at. I've given a window to use on the calculator. Let's make a graph and see what we're looking at here, and then we'll try to solve this problem. Okay, so I've got the calculator pulled up. I'm going to have to go to the y equals area to type in the equation. 2x squared plus 4x. I used the standard form. I could have put in the other form as well. And then I am being given a window, so let's match those numbers. It says to go -4 to 4 on the x-axis. Counting by ones seems appropriate. And then -4 to 8 on the y-axis. And then I'll hit graph. And here is a picture of our equation. It is what we call a parabola. A parabola is always what you get when you graph a quadratic function. So we're going to be making lots of these things. This point here at the very bottom is called the vertex, and you either have a point at the very bottom or you might get one that's upside down, in which case the vertex would be at the very top. Let's see. Now we were being asked, if you look back at the handout, to use this picture to try to figure out when f of x is 6. F of x, remember, is interchangeable with y. So I'm basically being asked, where is there a point on this graph that is something comma 6? One thing I could do to help myself out is I could go back to the equation area and just type in the horizontal line y equals 6. I think that'll help me to eyeball what's happening here. Let me go back to the graph then. So I'm essentially being asked what x value goes with this spot, and interestingly, it looks like there's another x value on the left over here. Well, this problem has been made up where it's easy to see the answers. We were counting by ones, so I think you can tell that this is the point 1 comma 6. And let's see, 1, 2, 3 on the left means that this point here is the point -3 comma 6. So we discovered that there are actually two x values that make the y come out to be 6, +1 as well as -3. That's pretty normal when you work with quadratic functions. You probably noticed that parabola was very symmetric looking, and so very often there are two x's that go with each y value. We'll say a lot more about quadratic functions in the lessons to come.